Hello and welcome everyone. In this day 22 learning, we are going to be understanding stacks and its operations that are done. Right? We are also going to be looking at few example problems that stacks helps us solve. And recently we have completed linked list learning, which is also going to be used in building a stack data structure. Right? So let's start understanding or giving a basic definition of what stacks is really about. It's a linear data structure where which follows first in, first out, first in, uh, last in, first out principle. Right? Last in, first out. Uh, we can consider it this way, where let's say have uh, we have some data. Let's say we have some data this way, uh, which are stored here. Let's say we have 3, 4, 5, and if we need to add in a data here, then we might need to use some sort of an operation such as push. Push 3, and let's say we want to uh, pop data from this data structure, then we might need to use pop, let's say 3. So these are few operations. We can also have few other operations such as uh, peak or top of the stack, get the topmost element of the stack, and also we can check if stack is empty or not. Right? These are few operations that we can have as core set of operations. Also, we can have some size of the stack at any given point. Right? So yeah. So stacks can be built in few ways. So we can use arrays. As you see, push and pop are part of the arrays. So implementation of a stack can be done with few ways, such as uh, arrays, and we can also do it with linked list. We can do it with static or dynamic arrays, but we are only going to be looking at dynamic arrays, and this is going to be implemented in JavaScript, which obviously has a dynamic size, right? The array size can increase as we push and pop. So I will quickly switch to uh, the specific uh, JSBin editor just to show out how the implementation is done. Okay, so here I have an implementation of stacks which is done through arrays. So let's say we initialize a stack array, and we have a constructor which says this dot stack initialized to an empty array. Then we can have a push operation which adds element to it, and a pop operation which initially checks if there is no elements. Then we return stack is empty, and peek to get the top of the stack, right? And is empty to check if to return the length of the stack, right? Okay, these are few set of operations. I will i will just comment these out just for our understanding. So I even have a singly linked list implementation of a stack here. So just for our reference, so let me just run this uh, stack implementation with array, right? So first thing is, here is the driver piece of code. First I have push 10 20 30, and peak is giving the top of the stack, which is 30 that was pushed at the top or the last element. And once we pop, so the last element which was inserted is being pushed out, which gives us the t, which is the last element that was popped out of the stack. And now the size is 2. Let's say if we add another peak element, this should give us 20, just for our understanding, right? As you see, this gives us 20, right? Okay, so this was about stacks being implemented in array. Similarly, I have uh, implementation done in linked list, which we are going to quickly look into the code that we have here. So stacks was pretty much easy, where we had an array and we used to push or pop based on the operations, which was very simple. And the time complexity of each of them is O of n. The operations or the actions that we are required to do with stacks is all O of n when we work with dynamic arrays, right? Dynamic arrays. Uh, Space complexity is obviously uh, size of the input, which takes O of n. While in case of linked list, we let's look at linked list, how we use linked list here. So okay, so so this is also a node. So this is like a singly linked list which has a value and a next pointer, and stack linked list implementation takes in uh, these two constructor parameters, which keeps track of size and top of the stack. And push value obviously creates a new node and moves the next pointer to the newly inserted value. In case of pop, we just remove the specific node, and we also uh, remove the next pointer or move the next pointer to null, right? So this is stack implementation. Let's quickly run this. As you can see, firstly we had pushed 100, 200, and 300 into the stack. And since we peak after inserting these three elements, we should be getting 300, and that's what we see here. With pop operation, we are able to see 300 being pushed out of the stack. And size is 2 since we popped out. So let's say we uh, push another value here, let's say 400, and then we ask for size. So this again goes to 3, right? Size is going to be 3. Size is going to be 3, and if we need to peak, the last element that was added is going to be 400, right? So yeah, okay. So I would leave this code snippet for further understanding, and I would paste this in the GitHub link in this video description for you to go through this. And let's continue and let's look at few direct examples, or the examples that can be asked in linked list, right? So let's switch back to uh, drawing board. And here at drawing board, let's also another thing that I wanted to uh, talk about is with sta- with time complexity in linked list. So it's all going to be open time complexity, right? And only comparison only advantage of using a linked list is the comparison. Array versus linked list is linked list grows smoothly as size increases, while uh, an array, if it has static value, cannot change size, increase. Else if dynamic, uh, then there needs to be a principle, either doubling size or size management gets difficult, is drawback. So these are the points that we need to understand. And in both cases, operations of linked list are O of n, and space complexity also here is O of n. And space complexity uh, in case of linked list might be higher. So that's one thing to keep in mind. Apart from that, these are the set of comparisons when we are implementing array and linked list. So it is easier to have it done with arrays, which is the fastest way. And coming to uh, examples of stacks, so we can have, let's say, balancing of symbols. Maybe we can have some code snippets. I would have code snippets pasted in the GitHub link. You can explore them, but just let me write down all the different possible problems or uh, questions that can come about with stacks, right? Balancing parenthesis, uh, problems such as infix and postfix. So infix or postfix, conversion of it, or even calculation. So we are going to be looking at this specific example or calculation, and also uh, browser function calls stack, right? We know that recursive functions obviously creates set of functions and they are executed in stack, right? In a stack format. And also another example here is browsing history, right? So another example might be undo and redo sequence, which can be achieved easily with stacks. And tags in HTML, uh, or XML is balanced or not. We can quickly test this with stacks. With uh, both of these might be a similar kind of questions, right? So yeah, these are few examples. Other places where stacks might also be used in other data structures is like trees or graphs, right? We might want to do traversal on a tree where a stack might be used, right? Okay, so we are going to be looking at postfix and infix problems. Uh, let's say I will quickly switch back to the editor where I am going to show postfix and infix problem calculation. And so let's say a problem statement is given to us asking for a calculation of let me switch to, yeah, JSPin, and let me paste the problem statement here. So evaluate a postfix expression where an expression like this, a string like this is given, and which equals 10, right? Operators come after operands. So these are the operands, and operator is the multiplication symbol or the asterisk symbol. No parenthesis needed. Uh, that's a condition in this problem. So we need to scan left to right, and operands are pushed to stack, and operators pop operands out of the stack. Right. Final result is the only element left in stack. Okay. The time and space complexity here is O of n, and space complexity is O of n. Right. There might be multiple other ways to solve this problem, but if we use a stack, we can get it done this way. So let's say, let's go through this specific problem in back in the drawing board. Let's think about how we can solve this with stacks, right? So let's say we are given with an example of, I will switch to a new page. 2 3 and 2 3 and 4. So that was what was given, 2 3 and 4, and yeah, this was the one. So let's say with stacks, we start reading this left to right, right? So we start pushing values to stack. So first thing is we see a number which is an operand, we push it to the stack, and 3 we push it to the stack. And once we see an operator or a symbol like multiplication, plus, minus, or division, or maybe modulus also can be asked in certain problem statements, then we pop the two operands out of the stack. Pop and operate, like 3 into 2, which gives 6, and this value is pushed back, right? So after this, so we would be ending up with stacks like 6, and again, once we have done this operator operation, then we again traverse through this input string, which is 4. Since it's an operand, we push it back to the stack, and again we see an operator which is plus. So we take the two operands, we operate with them, which is 6 plus 4, which gives us 10. So 10 is the output, right? So we push it back to the stack, and this should be the only value present in the stack. So this would be the only output. Okay, so let's switch back to the JS bin where I had a solution implemented. Let's understand what we had here, right? So for example, uh, let me run this. As you see, the solution for this problem is 10, right? So yeah, let's understand this better. Okay, so let's understand the solution implementation here. So we are initializing a stack, and for each character from this or function input, we are splitting them with the characters and space, and then we are pushing all the characters, uh, parsing it to an integer type and pushing it to the stack. Else if we find an operator, then we take the two operands, which are the numbers that are pushed to the stack, with a and b value, and we are using a switch statement to evaluate the specific character that was uh, that has been as an operator that we are understanding here. If it's not a integer, as we check in this regex expression, then we are considering it as an operator which we perform an operation with either these four cases, right? And the uh, final value uh, of this entire postfix calculation would be the last or the only value that would be left out in this stack. So yeah, hope this makes it very clear. As you can see, stack array is not defined. Okay, so I might need to paste in stack array. Okay, let me paste the stack array implementation and then the solution might work. Okay, let me try running it now. As you can see, the solution works, and that's for these three evaluation statements, right? Okay, with this, I will stop it here, and please do refer the GitHub file that I paste in this solution. I paste in this video description. Please do post your comments or any thoughts or any clarifications that you have with this tax topic in the comment section. And hope you found this video helpful. Please do like and subscribe to my channel. Thank you.